We're going to be looking at Unit 9 and what you need to know for your upcoming exam. We are going to allow one sheet of notes, so you can take the sorts and searches template document that you have been working off of and comparing sorts. You can use that template and make your own notes on it. This is a version of it that I have done. I've also copied and pasted several Wikipedia comparisons and other information that I have found, and we will review some of this. But if you have a handwritten sheet of notes front and back, you can use that on the next test. I'm going to take a look at the Unit 6 lecture notes to help guide this just a little bit. And so we are looking at 4 sorts, 2 searches, in the big O notation for such things. You are not required to do any assignments, coding assignments for this particular unit. You can if you like, but you don't have to. You should be familiar with the big O notation by now. And one thing to remember about the big O notation is when we look at the complexities and graph form, and there's several different websites and there's lots of links on course sites to this, but if you take a look at this, what's in red here, it shows you it's a horrible as far as efficiencies. And so we will talk about ON, which is a linear. We'll talk about n squared, which is quadratic. We will talk about n log n, ON, and then log n. And there's also a constant, which is just O1, which means it always returns a value in one operation. So actually, any method that returns a value is a O1, because it basically takes one calculation and returns a value very quickly. So when you're thinking of these things, come back to this chart if you need to. Write this on your cheat sheet if you need to, so you can easily kind of compare the speed and the efficiency of the algorithms. This particular website also has almost too much information, but it has down here our quick sort, merge sort, we do insertion sort, and selection sort. And so it does have some other information. You will want to kind of pay attention to the best, average, and worst case scenarios in some of these when you are working through them. When we deal with searches, which I don't see on this particular screen, then we'll talk about some best case and worst case here in a few minutes. If we go back to our lecture notes, if it's a quadratic sort, they are a sorting algorithm with a big O notation of n squared. And that means that you're attempting to sort an array with n elements. You're going to visit the number of elements approximately n squared times to get the job done. And so you can actually use this and do calculations. So like you can take, if I have 3 elements, 3 squared is 9, and so that means that tripling the size of the data set will result in a 9-fold increase. So I said that wrong. So if I triple the size of the data set, I get a 9-fold increase in processing time, as an example. So 10,000 elements, 3.5 seconds. 1,000,000 elements, 9 hours, as a comparison. You don't have to have this code memorized, but you do need to know the basic algorithms, because I know there's a couple test questions that provide an algorithm, and they will ask you what algorithm does this simulate, so to speak. And so you want to look for what we might do. Instead of doing low to high, it might do high to low, but you should recognize that whether it's a selection sort or an insertion sort, for example. And you should also recognize whether it's a sort versus a search. You know, anytime that this one's finding a position and then doing kind of a swap, it's doing a sort. If it's doing a search, it's going to be looking for an element and targeting that. So be aware of those algorithms. They are in your textbook, and some of them are here in the lecture notes. Topic 4 is just a review of random number generators if we were to do the exercises, but we are not going to do any coding. But it's often common that we write a program that counts in milliseconds the length of time that the exercises run, so we can do comparisons on our own, but we are not doing that. The merge sort uses a recursive algorithm, because it basically it's also a divide and conquer algorithm. So you keep splitting it in half, and then when you get down to a single element, then you merge it back up the tree, so to speak, so that when you're doing a merge sort, you will be using recursive method calls. This array copy here is also a nice little algorithm to know or be aware of, especially if you're taking the AP exam. That's kind of a nice one to know. Quicksort, again, you should be able to kind of look through the code. You are not going to have to know the code or memorize the code, and I wouldn't necessarily take the time to, write that out on your cheat sheet. You should have an understanding of basically how it works. You can go online and look at some of the algorithms that are there. There's lots of videos and stuff that you guys can watch. We have two types of searches. One is a linear search, and the best case scenario for a linear search is when the item is in the first element. The worst case scenario for a linear search is when the item you're looking for is the last element. The average for the search would be the number of elements divided by 2. And a binary search is what we call a divide and conquer algorithm. It is a log n. And so this particular portion of the lecture or the slides I really want you to pay attention to right here for this reason. Big O notation for a binary search is log n, and that means for an array of size 20, the maximum number of visits to the array should be base 2 log of 20, or approximately a base 2 log of 20, and that means it's between 4.32 or 5 visits. So base 2 log of 20 is 4.32. And so you have to have at least 5 visits to get an array size of 20 calculated. It's this base 2 that I want you to kind of pay attention to, because we're going to use that when we go through some of the review exercises and I do some calculations. This log big O notation is, it looks like it's base 10 here, and honestly you can use base 10 as long as you're comparing everything with base 10, or the actual calculations done are in base 2, but they don't usually write that out when you're using big O. Okay, so just kind of keep that in mind. But we use base 2 because when you're doing a divide and conquer algorithm, you're always dividing in half and half and half, and so it turns out to be a base 2 can model this very well. Unit 6 review. I am going to actually stop this particular tape or video, and then we are going to look at some of these review questions.